Alrighty guys, so this is just going to be a quick review. I'm going to use this Word document versus a Smart Slide, and I'm actually going to upload this Word document to the website. Should just be a quick review of some of the most important chemical reactions that you should know and you should remember from honors chemistry. I'm going to show you some of the ones that I think are the most important that you should know from honors chemistry. If you don't, just kind of look at how the reactants are written and what I'm talking about when I say, for example, chlorates and how they decompose. So the very beginning of this is really brief about how chemical equations are written and why they can be written that way. You can read through that. This was adapted from this link right here. So if you would like to visit that link, you can use that from the Word doc. Chemical equations show chemistry in action where formulas show chemistry at standstill. I thought that was a pretty neat way to describe it. This introductory information is really quite basic. One thing that I do want you to know are the diatomic elements, which are I say big seven in hydrogen. If you look on the periodic table, you'll see that nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are the big seven, and then hydrogen is the last one. Some of these other ones we'll get to in our next unit. I've also highlighted another important piece called the activity series. We'll start to memorize that next unit, but if you know how to use it, great. What you will be looking for is in single replacement reactions. A more active metal or non-metal will replace a less active one. I'll show you an example below. One more thing is that we will start to learn how things break down, how things will decompose because of their instability, and I'll show you some examples below of that as well. You can, if you'd like to start memorizing some of these examples, you don't have to until Unit 2, but this is a good document that you might want to save. Alright, so I'd like to go over some of the basic types of chemical reactions. Your first one here is synthesis. It just means to put two things together, or sometimes more than two things together. It depends on how complex we're getting here. Some of the examples that I need you to know are metal and oxygen make a metal oxide. You've got an example here. A non-metal and oxygen are going to make a non-metal oxide. So pretty much anything with oxygen is going to be an oxide. And make sure that you're crisscrossing here because we have an ionic compound because it's a metal and a non-metal. Down here we have a metal oxide and water combining to make a metal hydroxide. So if you ever have an oxide and water coming together, the way they come together is the oxygen kind of embeds itself within the water, and we may have two OHs, which in this case is magnesium hydroxide. We'll start to learn that non-metal oxides and water make acids. That's not as important just yet. Next one is just an ionic compound. We have a metal and a non-metal making an ionic compound. And then lastly, a couple of non-metals can combine to make some compound that's going to be covalent only. With decomposition, you need to know these three top ones specifically that I've highlighted in green. Carbonates are going to be, when they're heated, and technically I should have a little triangle over top of this yield sign to indicate that it's being heated. But all carbonates are going to break down the same way to make a metallic oxide or metal oxide and carbon dioxide. It doesn't just break in half to make calcium and carbonate because those are two ions and we can't have ions poofing out into thin air. We have to have actually compounds being created. So memorize that. Also know that metallic hydroxides are going to break down when they are heated as well to metal oxides, but water, not carbon dioxide here because there's no carbon in this metallic hydroxide here. And this is actually easy because it's just the opposite of the synthesis example above. Another one is a metallic chlorate. So chlorate is ClO3 1-. This is potassium chlorate here in this example. It's always going to decompose in the same way to make a metal chloride and oxygen. Don't just split it up like making two ions because that's not going to be possible. So you need to memorize these three. And going down, there's some more that we will start to learn about. We're just not going to learn about them yet. We will in Unit 2. Single replacement reactions, that's what I mentioned earlier about the use of the activity series. So in this example, compound or element A is going to be more active than B. So what it happens is it kind of scoots over here, pushes out B, and recombines with X to make AX plus B. Or, for example, this right here would be Y would be an active nonmetal or a more active nonmetal than X. And it's going to kind of scooch over here, boot out X, and then recombine to make AY plus X. Some examples here are below. Really the only one that we're concerned about are the ones that I just mentioned on that example, where we have a metal that's more active than another metal, or a non-metal that's more active than another non-metal. And those non-metals are usually going to be the halogens. And the last note down here says refer to an activity series. We're actually going to start memorizing that soon, so when we get into that, you won't be referring to one except unless it's in your head. Next, we have double replacement reactions. And if you did net ionic equations in honors chemistry, then you're going to be fantastic at this. It's just going to be actually writing out the ions that are participating in the reaction and not the entire compound, because we have things such as spectator ions, which we just pretty much ignore because they don't do anything anyway. They spectate, they watch. But the way that you would know something is actually occurring is that you would see a precipitate forming, gas forming, or water. Usually water is going to be from a neutralization reaction. So basic form is a couple plus a couple switch partners. So AX plus BY yields AY plus BX. So when we start to learn our solubility rules again, this will be important because it's going to indicate to you whether a precipitate forms or not. Here are two examples of that. The partners are switching places. They're making a precipitate, which we have labeled solid here. Again, aqueous, aqueous, those are two solutions. To make an aqueous, these are going to be spectator ions here, and the precipitate, which is actually involved in the reaction. Formation of a gas. Here we have H2S, or hydrogen sulfide, forming. This smells like rotten eggs. It smells horrible. And then lastly down here we have formation of water, which is from an acid-base reaction. And I told you it's called a neutralization reaction because we're making neutral water. Solubility rules will be important here. We'll get to that in Unit 2. Down here we have now combustion of hydrocarbons. So this is one, just combustion reactions are usually always going to yield the same products. It's pretty easy to remember. It's just kind of like cellular respiration in biology. So hydrocarbons are anything with C's and H's. Sometimes you'll have CH and O, like glucose, as your hydrocarbon, plus oxygen is going to yield carbon dioxide and water. This is what you need to know now. We're going to get to the incomplete combustion down here. And when I say anything burns, I'm talking about combustion. So those are just some tips on chemical reactions. Look back through this and look at the document that I post online. And if you'd like to view the actual website, it's got some good examples that you can actually work through. And that's it. All right, thank you very much. That was a quickie.